Says determine which postulate can be used to prove that the triangles are congruent. If it is not possible to prove congruence, then write not possible. Briley, are these two triangles congruent? Wow. Because all the sides, side, side, side. So to explain why these two triangles are congruent, all you have to put yes, side, side, side. That's your answer. Next one, are these two triangles congruent? What do you think, Carla? Yes. Side, 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 or side, side. Now I do know this. I know that this side is equal to itself. So does that help? Are those two triangles congruent? No, they're not. You need one of two things to know that they are. The top looks bigger, so it's looks bigger, and the looks. Never go by looks. You need to know one of two things. You either need to know, like he was talking about, you need to know that these top and this left side, if you knew those were congruent, yeah, those two triangles are congruent by side, side, side. Or, if you knew this angle was the same as this angle, that would be side, angle, side. That makes sense because of the angle between the two sides. But those two triangles aren't congruent. Dylan B, are those two triangles congruent? First off, can we use side, 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 Dylan? Why? All three sides are congruent. You got a tick mark here, tick mark here, tick mark here, tick mark here. Are these two sides congruent? Why? You can't go by looks, right? So those two sides, we cannot use side, side, side. Now the question is, what he was going for then, can we use side, angle, side? No. Why not? It's not, the angle is not between the two sides. Again, there's no angle side side theorem. I can write it down. There's no angle side side theorem, and there's no side side angle. If you want to say it like that, side side angle, which is what this would be, a side, and then an angle. There's no side side angle or angle side. No. Moving on. Are these two triangles congruent? Dylan Cooper, what do you think? You have sides that are congruent, and you have, and they didn't even have to tell you that, those are vertical angles, you knew those are congruent. Dylan, do you think those two triangles are congruent? Yeah. Yes, by what theorem? Perfect. Those two are congruent by side angles. Move along. Here's your next congruent theorem. Not only do you have side, 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 and side, angle, side, but you also have angle, side, angle. Notice where the side is located between the two angles. If an angle, or two angles of one triangle, are congruent to two angles of another triangle, the side between those two angles are also congruent, then the two triangles are congruent. They're identical. Everything about them is the same. Let's do a proof. It says write a two-column proof, and again, step number one, given. I'm not going to write down all that stuff. But it gives us that QS bisects PQR. Here's QS. It bisects PQR. It tells us that angle PSQ, which is right here, angle PSQ is congruent to RSQ. And it wants us to try to prove that those two triangles are the same. Matt, since QS bisects PQR, what does that mean is true? What's bisects mean? Cuts it in half. Cuts it into two equal pieces. Two congruent pieces, if you want to say it like that. So therefore, Matt, angle what and what are P, careful angle. PQS is congruent to angle what? Now, it's bisects the angle. Does that make sense? QS bisects this angle. So therefore, PQS is congruent to what? RQS. And that would be by definition of bisect. When you bisect something, it cuts it into two equal or two congruent pieces. Step number 3, we're nearly done. Somebody tell me where we're going to go with this. We now have 3 ways of proving that two triangles are congruent. We have side, side, side. It's going to be hard for you to use side, side, side. You have absolutely no information thus far about sides. You have side, angle, side, and you have angle, side, angle. Does anybody see 2 sides there that are equal? Does anybody know of 2 sides in these 2 triangles that will equal each other? Is this side equal to this side? It looks like it. Do you know it is for sure? Is this side equal to this side? Same reason. They look like it, but they don't know. QS is the same thing as QS. They share that third side, so therefore QS is congruent to QS. Why? Thank you. The reflexive property of congruence. Good. So therefore, are the 2 triangles congruent? The angles are the same. These angles are the same. This side is the same. So therefore, the 2 triangles, I can say triangle PQS is congruent to triangle RQS because of what? Perfect. ASO. Okay, y'all help me along with this. So again, statement number 1 given. And here, let's go through everything we're given. My first step, I always take my drawing, and I'll start marking everything that was true. It says ZX bisects WXY. Here's WXY is this angle. ZX bisects that. So since ZX bisects that angle, so tell me what's true. Which two? WZY?
Yeah,
Oh, sorry, WZY this time. So that means that WZX, right?
Yeah.
So we need to write that down. Angle WZX would be congruent to what? YZX. These 2 angles are the same, correct? Y'all follow that. Y definition of bisect. Now, it says that XZ also bisects YXW. So what's true there? What 2 angles are the same? YXZ and ZXW. Good. These 2 angles must also be the same. Now, if you wanted to, you can list that as step 3, but it's not for the same reason. So why not just list it right here below it? Also, because of that same definition, like you said, WXZ is also congruent to angle YXZ because of that same definition of bisect. And we're trying to prove that these 2 triangles are congruent. We have 2 angles in one that's congruent to 2 angles in the other. So we use angle side angle. XZ is equal to itself, or congruent to itself, because of the reflexive property of congruence. So therefore, since that's equal to itself as well, the 2 triangles are the same by what statement? Why are the triangles the same? Next, by angle, side, angle. Your next congruence way to prove the 2 triangles are congruent. The 4th way, angle, angle, side. Notice here you have 2 angles congruent to 2 angles in a second triangle. We're not talking about the included side, because then it'd be angle, side, angle. It could be this side, or if you want to get technical, it could be this side over here as well. That would also be angle, angle, side. Because you have 2 angles and a non-included side. If 2 angles and a non-included side of one triangle is congruent to 2 angles and a non-included side of a second triangle, those 2 triangles are also congruent. So thus far, we have side, 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 angle, side, angle, angle, side, and, or excuse me, side, 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 angle, side, angle, side, angle, and angle, angle, side. Let's do a proof. Lots and lots of proof. This is the best way to test what we know of these. Statement number one's given. Let's mark, let's see, DAC, that's this large angle here, is going to be congruent to, let me mark it with a different color. This one's a little bit hard to see. This one. So you have this angle is congruent to this angle. That's in the middle. You're also given a DC and BC. DC is congruent to BC, which is this and this. And we're asked to prove that the triangle ACB is congruent to ECB. And this, again, this is hard to see. Look what I marked this the same. This is the same as this. You see your two triangles there? See your blue triangle and your red triangle? And we're trying to prove, what do we have? In the red triangle, we have an angle and we have a side. In the blue triangle, we have an angle and we have a side. Does anybody see anything else? Because this is pretty short proof. Does anybody see anything else that's congruent about those two? It's an angle. They share an angle, don't they? They share angle BCD. Or could I just call it angle C? That's the only angle there. They share angle C. So angle C is congruent to, since they share it, angle C is congruent to angle C by the reflexive property of congruence. Every angle, every anything is equal to itself. And now, red triangle. Go to your red triangle. You have an angle. You have an angle. Now that's side. Is that side between the two angles in the red triangle? It's this side here. So you have this angle, and this other non-included side. Now go to your blue triangle. You have an angle, and you have this non-included side. So are those two triangles congruent? Yes. Triangle ACD is congruent to triangle ECD by what? Angle, side. Two angles in a non-included side is congruent to two angles in a non-included side. So let's mark everything we got. Well, they've already got marked. RQ is congruent to ST, and not only that, RQ is parallel to ST. And we want to try to prove that these two triangles are congruent. That's all you're given. There's several different ways you can prove this. Thank you very much. Because of alternate interior angles. What two angles are congruent? T and R. So let's do that. Step number one would be our given. I'm going to write it all out. Step number two, angle R is congruent to angle T. Because I'm just going to put parallel lines. I want to write this down. Parallel lines imply that alternate interior angles are congruent. Sometimes you might have parallel lines imply that corresponding angles are congruent. Sometimes you'll say parallel lines imply that alternate exterior angles are congruent. Sometimes you might say parallel lines imply that same side interior angles are supplementary. So that's supposed to be true. So you need to know why that's true. Step number three. Well, let's say step number two. You know something else is true because of that. Well, no, by this. Angle S and angle Q are also congruent because of alternate interior angles, right? Y'all see that? So not only is this true, but angle S is congruent to angle Q. And now we can go straight to our angle. So therefore, triangle RUQ is congruent to triangle TUS. If I did it this way, for what reason? Why are the two congruent? Angle, side, angle. Like I said, I didn't have to go that route. I could have stopped and said, okay, don't say anything about S and Q. What if I had stopped and somebody mentioned that vertical angles are congruent? That would be congruent to that. Angle RUQ would be congruent to SUT because vertical angles are congruent. Then you could say that the two triangles are congruent by angle, side. That makes sense. So there's several different ways you can go about these problems.